Question number 8. So this figure is showing an arrangement of resistance R1 and R2, which are arranged in parallel to a 12 volt power supply. So we have to determine the potential difference across resistor R2. So this is basically a diagram. This is where we have to apply potential divider lah. Okay. Okay. So now, first, remember potential divider is all about ratio. This is the ratio between voltage and the resistance. Okay, if it includes potentiometer, usually we have an addition of link lah. It's the ratio between all these three variables. Okay. So firstly, what we will be doing is we have to determine the potential difference across R2 here. So what we can do is by applying the potential divider lah. Okay, so V is the V that we are looking for, which is V on resistor 2. Okay, over the total supplied voltage, which is just V lah. Okay, so equal dengan the resistor yang we are trying to calculate, which is R2, and then over the total resistance. Okay, total resistance, which is R1 plus R2. Okay. So from here we are just looking for the potential difference across resistor number 2. So rearrange that, we should get something like this. So this is basically the concept of potential divider. Okay, you should just be able to understand that it is basically just the ratio between voltage and resistance. Okay, so this would give us a value of 6 volt to be the potential difference across resistor R2 lah. Okay. Now question B pula, R1 here, it is replaced and calibrated with a variable resistor. So now it is RV. Okay, so what would be the resistance RV if the reading of the voltmeter is 5 volt? So the reading of the voltmeter is now 5 volt. Basically we are still using the same concept, except R1 is now a variable resistor lah. Okay, so I'm just gonna put that like that. So based on the question, we have the new potential difference, which is 5 volt. Okay, so now from here it is equal to R2 RV plus R2. Okay, R1 tu kita tukar je pergi RV, which is the variable resistor. The supply voltage is still the same, which is 15 volt lah. Okay. So from here kamu substitute lah 5 equal to this one is berapa tadi, 2. So RV plus 2 times dengan 15 volt. So from here you should get the variable resistor to be equal to 4 ohm lah. Okay. Alright, so it's actually very simple if you just try to understand it as it is, which is a ratio lah. Okay. Okay, so question C pula, does the power dissipated by R2 increases, decreases, or remain the same? Okay, so firstly we look at when R1 when V is equal to 6 volt and when V is equal to 5 volt lah. The first situation is when the potential difference is equal to 6 volt. So first we know that the power can be calculated using the formula V over R. Okay, so in this case the power for the situation where the potential difference across resistor 2 is 6 over resistor 2 is 2 ohm, so this would be equal to V square. Sorry, I forgot the square there. So it should be equal to 18 watt. Okay, and then when the potential difference is now equal to 5 volt, we have to calculate this is initial lah. Okay, we have to calculate the power lagi lah. So the power is over the resistor number 2. So this is 5 over 2 square. So this would be equal to 12.5 watt. Okay, so if we see the value of the power during 6 volt is greater than the one when it is 5 volt. Okay, so the power dissipated by R2 decreases lah. Okay, so the answer is decreases. The power decreases, okay, when the variable resistor is used. Okay, so that is the solution for question number 8.